Welcome back to Advent of Code 2025, Day 2. Gift shop. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole, gleefully exclaims a nearby sign. You aren't sure who is even allowed to visit the North Pole. You know you can access the lobby through here, and from there you can access the reset of the North Pole base. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. As it turns out, one of the younger elves who's playing on a gift shop computer managed to add a whole bunch of invalid product IDs to the gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? They've even checked most of the product ID ranges already. They only have a few product ID ranges, your puzzle input, that you need to check. For example, 1 to 11, and so on. The ID ranges are wrapped here for legibility. In your input, they appear in a single long line. The ranges are separated by commas. Each range gives its first ID and last ID separated by a dash. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. So 55, so on would all be invalid. None of the numbers have leading zeros. This isn't an ID. 101 is the valid one. Your job is to find all the invalid IDs that appear in the given ranges. In the above example, 11 to 22 has 2 invalid IDs. 95 to 105 has 1 invalid ID. Repeated twice. Adding up all the invalid IDs produces this. What do you get if you add up all of the invalid IDs for the puzzle input? Okay. Put that there. Could also try with this one first. Maybe one line. Just need line and comma. Get the ints. Oh. No, we'll map each line to each range. Split like this. Then you have the first part. And the second. Oh. And it can be a range, right? So this is a list of int ranges. Then I can say each range, check how many invalid integers are in there. if the number in the range what's the definition? Which is made only of some single digit repeated twice. So split it in half. Go back to string. Let's just go with this. So let's just do like half of them. Drop half of them. If this is the same, then we can add it to our results list. Here we have 8, but we would sum them. Then we get this number. So if we do it here, we need to use too long, it seems. And check. This has to be a long again. And we get this result. And that's part 1. Part 2, the clerk quickly discovers that there are still invalid IDs in the ranges in your list. Maybe the young elf was doing other silly patterns as well. Now an ID is invalid. It is made only of some sequence of digits repeated at least twice. So now an ID is invalid at least twice. Okay. So basically any combination of where the repeating can happen. Or it can happen 3 times. I can split it different ways, basically. So we have this. I mean, how long is the longest number? Probably 5 or something. 10. Yeah, so we have to go also split in 5 parts. I could say this is um, D, and I do it for 2 to 5, map this, and then we just say D is this and not like that. Then we always map this. Everything is repeated mm, is one of them. Any of these need to be true. But it's kind of like wrong. Make this a method and say these kind of like times. Hmm. Adjunct AD times. And then basically it. I'm gonna say like this. Okay, say we chunk it. Chunks. And then I fold the chunks instead of, well, drop one. Start with the first one. I don't have to do anything crazy now, actually. I can just go is repeated. And then I go have like a baseline, which is my chunk's first chunk. And I go to chunks for each and say is chunk can say, are they all? And so to say matches dot, they're all true. So if it's like 2, it is the same as before. Times repeated. Otherwise, we can even, yeah. So we just go, and then if any of these patterns match, so all of them repeated, then we add it to the list. Check if makes any sense. Wonder if I do 2 here, it's the same as before. 2 to 2. Looks too big. No, it should be a big number, right? What was the answer? 373. Okay, not that big. Hmm. Hmm. Okay, I'm chunking the wrong way. I'm getting times is 2, but I'm getting 4 chunks, but I want 2 chunks, which means this, I think. I get 3 chunks. Hmm. Doesn't evenly split it, then I think we can ignore it. I think that works. Why is there only one match though? Okay, no, that makes sense. This goes on until we hit 100, 100, or I guess. I gotta move the point a bit. Okay, we got this much, that's great. I get such a high number. I'm actually printing my results so I can see here. This one. Matching. Let's just do a check here. These two chunks. And then we have oh, I'm silly. I found the silly mistakes. I need to check if any have. Like this just checks if any exists, I guess. The collection has one element. I need this one. If the collection has one element, that is true. Now we're back to here. And then we can do 2 to 5. And a few more, so that makes sense. Still too low. Hmm. I don't know if we can get more in. This is not that race. It's the same number. Let's check this example again. Was this right? Aha, I get the same number with the example. There must be some other edge count. Maybe larger numbers. get the input again. I mean, there's somehow a way to make even more. Okay. So let's go through the solution. Part 1. We need to make these int ranges. Where Kotlin has a nice functionality. You can just do a dot dot b and then you get an int range. Oh, sorry, long range. And then I can just go through all of the ranges. For each range, I check each number. For each number, I pass it to a string first. Number as a string. Then I go into, for part 1, I only need to check for 2, which is 2 will be the amount of times I split my string. So if I have a string, I can say 1 to 3, 1 to 3, and then I split it into 2 parts. And I see this is true. Then I can compare them. So what chunking does is it takes a string and makes a list of strings that are in the size my input string dot length divided by times, which is, for example, if times is 2, half the size here, and check if it's equal length. In the equivalence check, I take the first one, then I take everything except the first one, and check if those match the first one. So baseline is this, and each chunk is just this one, and then I check if they're matches. If they're all match, so this gets just 1, I return true. So if it's true, then I add it to my list. For part 2, so at the end I can sum this list and then I get the result. Part 2, I do the same function with 2 to 7, so I split the string into 2 equal length strings, and then I split into 3 equal length strings up to 7 equal length strings. Check if any of these splitting numbers return me is repeated for my string. Then if any of them repeat, so if I find a way to split the string, for example, 2 would map to 1, 2, 3, 3. And 3 would map to 1, 2, 3, 1, 1, 2. And I would check on these, and this one would return true. It's equal, and this one would return false. But then because one of them is found one way to split my string, I can add to my results and sum the results. And that's the answer for day 2. Enjoy the rest of your day.